All right, yes. Gases are good. Hi, you're fine. All right, gases are cool because you can actually either compress or expand them. Which one means to get bigger?
Expand.
Expand, okay? So expand means I can make the particles bigger, not necessarily the particles, but they can take up more room. Or compress, I can get all those particles who typically like to be very far apart, and I could put them in a very small space. For instance, Mandy, I think you will be very good at this. You ready? Okay. Are you there, Mandy?
Yes.
Yes. Okay, Mandy. If you open a soda, whether it's a bottle or can, what sound do you typically hear when you open it? You have to illustrate for us, please.
I can't make that sound.
What? You can't make that sound?
No.
Yes, you- Come on, try for us. I believe in you.
Like a
Okay, good enough. Right. All right. It makes it like a or whatever, however you want to do it, it makes that sound. That sound is the sound of all the gas particles being, I'm free, and they're going out and spacing out like they want to, right? We took them and we compressed them into a very small space, a 12-ounce can of Sprite or a 20-ounce bottle of Coke, and they're in there. And that's why all those bubbles are in there as well. And as soon as you open them, they go away, okay? Or they escape, which is why if you leave it open, the soda goes flat. There's no gas in there anymore. All right, so gases are indefinite shape, all right? Indefinite shape. And you can compress or expand those particles. All right, we're moving on to volume now. Moving on to volume. Solid. So remember, volume is how much space does it take up? Can I change how much space it takes up? All right, solid. How about Posey, what do you think? Volume, definite volume, or can it change for a solid?
It's definite.
It is definitely definite, okay? It's definitely definite. All right, so yes, for a volume, you have a definite volume. Oof, my writing. I gotta get used to this board. I have to consciously pick up my hand. Definite volume. Right, very slowly. Is a definite volume. The amount of space it takes up is the amount of space it takes up. This mouse takes up this much space. There's no way I can stretch this mouse out and it take up more space. It's a solid. This is how much space it takes up. Okay. All right. Paul, how about for a liquid? If this takes up this much space in this bottle and I poured it into something smaller, would it just take up just that much space or would it run over?
Well, it'll fill up the space.
It would fill up the space, but then with all, like if I had a cup this big and I tried to pour all this in there, would it all fit or would it run over?
It will run over.
It's gonna run over because however much space this is taking up, that's how much space it has to take up. It cannot change. So this one's also a
Definite.
volume. Very nice. Thank you. All right. And a lot of times, just as a side note, guys, when we're talking about volume, it's measured in like, it's like when we're talking about, like if you look at your bottle, it's like, is this many milliliters or liters or a gallon or ounces? That's what we use to measure volume, okay? All right, so then we have gas particles. I think it's important to note that we had already said they are capable of being compressed or expanding. So what do you guys think it is going to be in terms of the volume? What do you think? Definite or indefinite? Kayla, what do you think? Definite or indefinite?
Indefinite.
It's definitely indefinite. Indefinite. It can change, okay? So So much so, has anybody ever bought a balloon and then after a while, you didn't pop the balloon, it didn't open, it didn't have a leak, but all of a sudden it deflates, like it's like in the air and then it kind of like deflates and it's no longer floating. Anybody, that ever happened to anybody before? Okay. All right, with gas particles, when we're talking about like if they get hot, they tend to move faster, or if they get cold, they move slower, so they're not bumping the walls as much. And so that's why your balloon deflates, okay? This is an indefinite volume for that one. I didn't write volume, but volume. All right, so let's say, let's talk about the particles, okay? And we said the particles, I think we already talked about it. We said those particles are called, oh my goodness. They're called atoms. Okay. All right, so let's just pretend that we were taking the same amount of space, but we're looking at a solid, a liquid, and a gas. So let's just say we looked at, we zoomed in, okay? So we're looking at a portion of the stuff in this bottle, a portion of the air in this room, and a portion of the stuff in this mountain. So let's just say we zoomed in, all right? So we're looking at just a space this big. Okay. In a solid, what do you think the particles are going to look like? Are they going to be happy and free and very far apart? Are they going to be kind of close to each other, kind of hanging out? Are they going to be up on each other? What do you think in a solid? I can call someone. Volunteer. James, what do you think? How are the particles going to look in a solid?
Up on each other.
They're going to be up on each other. Very nice. All right. So in a solid, you have these particles, okay? And they are right up on each other. Okay. And really, oh my goodness, this board is so sensitive. All right. And really, there's even less space in between them than this, but I'm scared if I draw them any closer, it's just gonna be like one big blob. Okay. But they are right up on each other. All right. Now, here's the interesting thing that most people don't know. Those particles, like if I'm thinking about the particles in this mouse or in this desk, they're actually moving. But they're so close to each other. It's like if everybody was packed out in this room and you're like trying to get by, you're like, excuse me, excuse me, excuse me, excuse me. They're just kind of vibrating in place. Okay, so technically they are moving. They just vibrate. Oh, vibrate in place. That says vibrate, by the way. They are very close together. All right, very close together. All right, now I'm just gonna make a note because sometimes when we draw these pictures, people like on the video yesterday or on Wednesday, Monday, it looked like there's less particles. There's not less particles in a gas, okay? It's just they're further apart. So I'm just gonna count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11 particles. So I'm gonna make sure I draw 11 on all of them, all right? Now, in a liquid, they're not as close. They got a little bit more wiggle room, but they're fairly close to each other. So if I draw 11, 1, 2, 3, 8, 9. All right. So they're close to each other, right? They're in proximity, okay? But this is why a liquid can take the shape of its container, right? Because it's kind of like, oh, excuse me, I can just glide past you, however you want to say it. So these are loosely packed together. Okay. And we can say slide, we can say glide, we could say flow, however you want to say it. They can roll, however you want to say They move past each other. Slide, glide, flow, roll, whatever. They can move around each other. Those solid particles are up on each other. They're not going anywhere. They might be moving in place, they're not going anywhere. All right. Gas, these are the party particles, okay? They are all over the place. If they can be far away from each other, they will be, okay? Now, if I need to compress them, I can get them close together, but like I said, as soon as they get the opportunity to space out, like we talked about opening the soda, that's what they're gonna do. So in a gas, they are very far apart, all right? So if you want to, you can go ahead and start throwing your dots. I did 11 dots on each of these, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very far apart, okay? But again, the gas ones are kind of cool because I can push them together if I want to, okay? Oh, I was like, whoop. Everybody can see what I'm drawing this, just make sure. All right, so they are very far apart, all right? All right, any questions about states of matter or phases of matter? You should know for quiz, a couple of things. All right, let's just talk about what you need to know. If I ask you who has a defined shape and a defined volume, you should be able to tell me that's a solid. If I ask you who can compress or expand, you should be able to tell me that. If I ask you anything about the shape or the volume, you should be able to tell me that. If I ask you who's loosely packed together or who can slide, glide, flow, and roll past each other, who vibrates in place, who is very far apart. Any of those, you should be able to tell me solid, liquid, or gas. Any questions about this? Okay. Does anybody still need me to stay on this screen before I change screens? You will have to unmute and tell me so. All right. So now let's talk about physical and chemical properties, and then physical. We're not going to talk about chemical changes today, but physical changes. Physical changes. All right. All right. So we're going to start out talking about physical and chemical properties. That's what we're going to do. So we're going to do physical properties, except for that's my hand. Physical properties. We'll start here and I'll just tell you, and then we're going to talk about chemical properties. And then after that, we're going to talk about physical changes. Okay. And physical properties and physical changes are fairly close together. All right, so when we're talking about physical properties, okay, these are the physical property of something, okay, physical property of something, let me change my pen here, is when you use your 5 senses, okay, kind of like when we talked about qualitative data, okay, we talked about qualitative data before, remember that stuff that has to do with your 5 senses, okay? So we're gonna use our 5 senses to make observations about a substance. And a substance is just whatever thing or compound we're looking at in chemistry, okay? So we're gonna use our 5 senses to make observations. Observations is just, oh, what does it look like? What does it sound like? Okay, there are some that you don't necessarily use your 5 senses for, but the important thing is when I look at a physical property, nothing about the substance is changed. Okay, that's the really important thing, okay? Because when we start talking about chemical properties, the stuff about it will change, all right? So, what was I gonna say? I was gonna say something else, you guys. Yep. All right, so you're using your five senses to make observations. Nothing about the substance has changed. So you could do a measurement as well, but again, nothing about it is changed, okay? So for example, now you guys can't touch this. You can't smell it, you can't hear it, all right, but you can see it. Brooklyn, tell me one thing you noticed about this.
Sorry, I can't see your card.
Just tell me one thing you noticed about this.
It's red.
Thank you. It is red. That's the first thing I noticed, okay? So color is a physical property, okay? Color is a physical property. All right, so we're just gonna write some examples of some physical properties. Example, color, very nice. All right, Gibson, what else do you notice about this? Anything you can tell me about this?
Are you talking about that card?
Yeah, can you tell me anything about it? Brooklyn said it's red. What else could you tell me? Anything
It's made
at all?
out of paper.
It is made out of paper. Very nice. So it's made out of paper. So what it's made out of is a physical property. Anybody can tell me the shape of this?
Rectangle.
It's a rectangle. So shape, okay. If I ask you guys, if I could, ooh, good question. Yesterday or Monday, whatever, everyone was telling me, someone told me that all matter is made up of two things. What was one of the things? Starts with an M. You would need a balance for it. Not how much it weighs. We wouldn't say weight.
Molecules.
What is it?
Molecules.
Not quite. What's something that sounds like weight, but it starts with an M?
Mass.
Yes, very nice. Mass, okay. And then how much space it takes up. What's that word? It starts with a V. We just talked about it.
Volume.
Volume. Very good. All right, mass, volume. Anybody remember anything else from the video? What about like if it floats in water or not? What was that? Anybody remember what that was? It started with a D.
Density.
Very nice, density. All right, all of those. Ooh, what if I told you, hey, I know you guys can't touch this, but this is very smooth. What about that? What's that? Starts with a T.
Extra.
Very nice. Okay. Very good. All of those are physical properties. Those are examples of physical properties, okay? I'm gonna give you a couple more just because we talk about them with metals. You may remember them, I know this is stretch, but you might remember them from physical science. There's 3 properties of metals, and you don't necessarily have to know which one is which, but one is, can you bend it? One is, can you draw it into a wire? And one is, if it's shiny or not. Anybody remember any of those? One starts with an M, one starts with a D, one starts with an L. Anybody remember those? And it's on your notes. Were you saying something, Brooklyn?
No.
Charlie, you're back. You got one? How about, do you know what it's called if it's shiny or not? It starts with an L.
I do not know.
Okay. It is luster. That's an L, guys. Okay. Malleability is if you can bend it or not, like if you got a wire hanger. Okay. Or even here, my mask. You know, some of the masks have these. I have like this little piece of wire in here, and I can bend it to go across my nose. That's malleability. I can shape it, okay? And the other one is ductility. And I'm trying to give you a lot of examples because I know they're gonna be on your quiz. If you didn't hear me, I said I know they're gonna be in the quiz. All right, chemical properties. All right, any questions about physical properties? All right, let's talk about chemical properties now. All right, when it comes to chemical properties, you typically have to do something or know that if you were to do something, it would change the substance you have. Okay, so like for example, it really has to do with, will it react with something else? Okay, so chemical properties has to do with reactivity. Okay, so you basically have to do an experiment. Okay, and when I say experiment, it could be like set something on fire. Okay, I'm not encouraging you to set anything on fire. I'm just saying. Okay, but what's going to happen is if you were to do something, okay, remember how up here, nothing about the substance is changed. Now down here, it would change. Okay, so now, okay, the substance would change. Would change. All right, the substance would change. So for instance, one of those properties may be, they talked about in the video, they talked about two of them, they sounded very similar. What do you call it if something catches on fire easily?
Flammable.
What is it?
Flammable.
Flammable, right? So flammability is one, okay? And there's two of them that sound very close together. I just forgot how to spell flammability. That might not be right. Sorry. That's why I teach science, not English. Flammability, and the other one is combustibility. Okay. Combustibility. Okay, combustibility. And they are very similar, except for one is like, if I were to light it on fire, it will burn. The other one's like, if I try to light it on fire, it's gonna ignite very, very fast, and it's gonna burn very, very quickly. So like gasoline is both combustible and flammable. It's probably gonna cause an explosion, okay? A tree is combustible. It will burn. I might have to hold the fire there for a second, but it will start to burn. It's not flammable though, okay? Combustibility, flammability. Reactivity with an acid. So if you see like acidity, or it may say something to do with the word acid, okay? Like for instance, I can take certain metals, and if I pour an acid on it, it will start to bubble, and it looks like it's melting, okay? It's not really melting, but it looks like it's melting, okay? Flammability, combustibility, acidity, those are examples of chemical properties, okay? All right, let's see. Any questions on chemical properties? Okay, anybody still writing?
I am.
Okay. All right, so we talked about physical properties, okay? These are things that we can observe, all right? Now, all right, now I want to talk about physical changes, all right? So for example, Angel, I have a sheet of paper. Tell me something I could do to this sheet of paper to make it look different right now. Like right now.
Fold it.
I could fold it. That is a physical change. I have now folded the sheet of paper, but it is still a sheet of paper. All right. Somebody tell me something else I could do to it. Teresa, what else could I do to this sheet of paper? No, Teresa? Anybody nodding? Tell me something I can do to this sheet of paper. That'll still be a sheet of paper, but I can make it look different. Okay. All right. Anybody? Tell me something
You
else.
crumble it up.
I can crumple it up. Still a sheet of paper. Yes? Okay. Physical changes are things that you can do to change something, but it's still what it is. Okay. It is still what it is. So physical changes, okay, changes that do not change what the substance is. Change what the substance is. Okay. So Angel said I could fold it. Yes, it's still a sheet of paper. Posey said I could crumble it. Yes, it's still a sheet of paper. I could also rip it. It's still a sheet of paper, okay? I could fold it, I could tear it, I could rip it, all those things, okay? I could even throw it in some water. It's still gonna be a sheet of paper. It's wet, but it's still a sheet of paper, okay? So those are examples of physical changes. Chemical changes, which we're gonna talk about next week, would change it. If I set this on fire, would you make some new stuff? Tell me what you would see. What would you notice right now if I set this on fire? How would this piece of paper look different? Or how would it look different in general? Y'all really gonna make me call people every time. All right, Caleb, how would this look different if I set on fire? Tell me something you would see.
It would be burnt.
It would be burnt. It would change colors. You would see ashes. You would see smoke. It would be hot. There would be different stuff because that's a chemical change. Me balling this up is still a sheet of paper. All right. We got one more thing to go through and we'll be done. So physical changes. We're going to talk about another part of physical changes. Okay. And those are phase changes. All right. Phase changes are tricky because people want to think that phase changes change what you got, but they don't. Phase changes are physical changes, okay? And this is how you remember it, physical changes. Really easy, okay? Phase starts with pH, so does physical. Phase changes are physical. We're gonna go through all of these. We're gonna make it. All right, you got 3 states of matter. Paul, tell me one state of matter, or tell me all 3 if you can.
But you got what, a solid, liquid, and a gas.
Very nice. Solid, liquid, gas. All of our phase changes just means you're switching between those. All right. Brooklyn, if you put a bottle of water in the coldest part of your refrigerator, what happens to it?
It freezes.
It freezes. Freezing is a phase change. Somebody tell me the opposite of freezing.
Melting.
Melting. If I leave my chocolate in the car, it is going to melt. Anybody know what all the water on the side of your nice cold drink is called? If you got a cold drink and then all of a sudden the cup is wet.
Condensation.
Condensation. Very nice. Okay. What if I have a pot of water on the stove and I
Boiling?
and say again?
Would it be boiling?
Yes, so, and this is a good point. Okay, so boiling is a type of what we call vaporization. What's another word that sounds like vaporization? Vaporization or vaporation or
Vaporize?
evaporation. Yes. Okay, so you can see it a couple different ways. So I'm going to put vaporization, and we'll talk about it. But realistically, if you see vaporization, or as Posey said, boiling or evaporation, those are all the same thing. Okay. The difference is where does it happen? Okay. All right. Now, the other two you probably have not heard of. They should have been in your notes though. One was called, oh, did you guys hear my knees? Those are my knees popping. Sublimation. And the other one's called deposition. All right. So now we just got to figure out what is it going, what's it starting at, and what's it going to. For instance, freezing is starting at something and changing to something else. So it's got to be one of these three.
Liquid to solid.
Very nice. Liquid to solid. Thank you so much. I'm gonna do my arrows all the way down. Arrow. I'll just do it the same color. All right. So liquid. Leave me alone. Go away. Go away. Solid. All right. And the good thing is these are opposites. These are opposites. These are opposites. So melting is
Solid to liquid.
solid to liquid. All right. Condensation, we said you ended up with a liquid on the side of your glass.
Liquid to gas.
Liquid. So what did it start as?
Liquid.
Nope, gotta go to
I mean gas to liquid. Would it be gas to liquid?
very nice. Gas to liquid. All right, so that means this one's opposite. Evaporation, you go from a liquid to a gas. That's why when you're boiling, it looks like it disappears, but it doesn't. It just turns into a gas. Okay, and then these are the tricky ones. Sublimation. This is a solid to a gas. That sounds really weird, right? And a gas to a solid, but who's heard of dry ice before or seen it? It looks like it's a block of something and then it just turns into smoke, right? That's what they use at like the concerts and stuff. That is solid carbon dioxide changing directly to a gas, never turns into a liquid. It doesn't melt. It goes from a solid to a gas, okay? And it's actually kind of cool because realistically, when we think about boiling, we think about stuff being really hot, but because carbon dioxide is used to being a gas, for it to be frozen, it's like, oh my gosh, room temperature is boiling, so it turns into a gas. It's really boiling. All right, make sure you have all these down. If you didn't do your video notes tonight, from Monday, you're gonna make sure they're done by Monday. We're gonna have a quiz over the stuff that we did on Monday. Hasta luego. Have a great week.
Bye.
Bye. See you later.